All right, good morning, everyone. Good to see everybody. My name's Chris Chapman, and I'm going to be talking to you about unlocking virtualization for your organization today. So just a bit about me. I'm the CTO and SVP of MacStadium. I've been in tech for longer than I care to admit, and trying to jam Mac into that tech world even longer. So who is MacStadium? So we've been around for a better part of a decade. We basically work to try to create Apple as a first-class cloud resource, which isn't as easy as it seems because that's not what it's for. We build it in an enterprise-grade fashion, and we deliver it globally through data centers everywhere. And then beyond just the physical hardware, we actually build software and solutions around that. So we're really keen on solutions for Mac, on Mac, as a cloud solution. And in general, you'll hear me sort of iterate this term throughout the talk, but what we really hope to enable is what we call Mac DevOps, and that's beyond the normal DevOps and with all the considerations and concerns that Apple brings both as a local device and something that's non-local as well. Let's talk about virtualization. This is not exactly the newest technology in the world, let's be honest, but in the world of Mac, it has gone through iterations and it has some interesting significance and change. So in general, virtualization is abstracting your hardware away into a software-defined environment. That usually means passing through or abstracting drivers and devices and basically giving somewhat a bit of portability to your OS and your environment. But why do you want to do that? Well, there's a couple of key areas where virtualization actually is a helpful technology beyond, obviously let's talk about the elephant in the room that abstracting something on top of something doesn't make something faster necessarily per se. Hardware is going to be hardware. So the closest you get to the hardware, the faster your performance is going to be. So virtualization in and of itself isn't some kind of massive performance uplift over Apple's hardware. They do an amazing job of creating an OS that runs the hardware as best as possible. But virtualization does give you speed, capability, and flexibility in other ways that then draws out more capability from that hardware. So it really boils down to how and where you apply it. So development and testing is a place where you see it a lot because you're going to run multiple configurations of the operating system over and over repetitively. You're going to put a lot of different configurations and tools in place, and you're going to have those shift about. They may be individualized to different developers. They may be individualized to different build systems. So that's a place where it makes a lot of sense to do virtualization, else you're imaging and managing your hardware over and over at a pretty rapid clip. Learning is another area where you can actually apply this. Throwaway environments where you can basically explore and crash and correct without fear of having administrators scream at you for doing whatever you did to their poor device. So, that's something that's pretty significant. Security is another area. We'll get into this as we get into the newness of some of the Apple Silicon virtualization, but abstracting out resources, whether they're kernel resources, whether they're device drivers, whether they're user or configuration tools, that becomes pretty key and pretty important, and virtualization has a hand in it. You can count on virtualization in general. Like I said, this is not a new technology. If we kind of go back to broadly virtualization, we're talking 30 years old. When we're getting more specific, again, Apple's done some interesting things in the past couple of years with their new hypervisor that changed the game on the Apple platform. But what you effectively do with virtualization is provide portability, scalability, and flexibility. So you've encapsulated what you want, and now moving it about, changing it up, scaling it up becomes significantly easier. So let's talk about the sort of loose history of virtualization on Apple. So there's been, in the early days, what we called the Hackintosh. That was basically rip the poor Mac apart and try to do something unholy to it to get some other operating system or some other configuration to run in your way you want. This was not supported or blessed by Apple per se, but nonetheless, it didn't stop all of us from trying and seeing what we could do with our Macs. Powerful hardware makes you do powerful things. So as you move forward, though, proper forms of virtualization did come into play. VMware, obviously, leader in virtualization technology, started out and added ESX, but Parallels and Fusion are two other formats. If you're an admin, you probably run into Parallels and Fusion more than you do ESX, because that's the desktop form of virtualization that lets you cross-platform things like Windows or Linux on your Mac, so you can get portability of applications that may not be Mac native. But ESX is really where it started to have applicability into larger scale environments, IT closets, data centers, the like. That effectively still meant erasing Mac OS and putting a virtualization layer on top of the Apple hardware, but then it allowed you to actually virtualize Mac OS right back on top of it. Beyond that, you get into different flavors of things. Docker on Mac is something that folks have started to use, especially in development. That provides an Xhive kernel inside the OS, so it's using containers, it's not using Mac OS virtualized. So it's a bit of a twist inside the OS so that you can actually do Linux containers on your OS and provide some capability for developers who like to do smaller features and workloads that way. And then there's the brainchild of MacStadium that I had a hand in called Orka, where we took the Docker thing and flipped it inside and out. The internal code name of Orka originally was the Turducken, and it was because we were doing things that weren't exactly normal. We basically wrapped containers around a virtual machine on a Mac, deployed similarly to VMware, where we provided a virtualization layer on the Apple hardware, but then more similar to the Docker version you see there as well, where we containerized the actual OS itself. And we did all that because we wanted fancy hooks to be able to orchestrate a VM, but we wanted to use it like a container. So that's some of the weird stuff that people have done over the years. And we were cruising along with our Orka stuff and pretty proud of ourselves. And then Apple gave us a present called Apple Silicon. And it actually was really cool, but you can imagine after spending years building an architecture based on Intel, it's a bit of a shock. So that's a shift away from the Intel x86. So immediately Hackintoshes gone. VMware breaks, Orka breaks, things break. But then it makes us ask, well, what's Apple up to here? Why? You know, they had lots of whys, obviously. The hardware platform itself is leaps and bounds above other existing hardware, performance, capability, et cetera. But the embedding of virtualization was a purposeful and intentional step to Apple, not just for VMs, which it is useful for, but it's really a different approach to the kernel. It's a different approach to security. It's a different approach to how they expect devices in the world as we evolve forward beyond just the desktop and into extended things should work. So when you drill down into the actual code base and you start to see what it is, you realize that the kernel is becoming sacred space. And that's for a lot of good reasons, right? And one, to keep the optimized performance really tight-knit and not get mucked up with things that we all tend to like to do. I know I'm a fan of injecting text as much as the next guy, but they can cause all kinds of serious problems. And Apple kind of, rightly so, wants to sort of mitigate that. A bigger problem that companies like Apple face is security, and that includes state actors. I'm thankful I'm in a job where my code is not being attacked by state actors, but Apple's definitely a device in a place that is. Virtualization for them is a way to basically say, hands off the kernel, there's no valid reason for you ever being in there, but here's a virtual interface where we have a clear boundary and a clear way to control it, and here's how we can let you interface. So you'll start to see that when you dive down into the hypervisor framework. It also was a positive thing in that because of that, they're having to expect and make everything work through virtual interfaces, which means the performance can't be the same 10-20% overhead penalty that it once was when you used a type 1 hypervisor or erased it or tried to do nested virtualization inside the OS. It has to be sort of a first-class citizen in Mac OS. And Mac OS has to treat it like it were almost a native device. So that really unlocks a bunch of different performance levels, and it paves the way again for sort of a broader conversation as Apple starts to evolve the device formats and factors and the way we might interface to these devices and where those devices may or may not live. It kind of unlocks all of that. When you talk about the actual virtualization layer on Mac itself, you're really talking about two things, a hypervisor framework and a hypervisor toolkit. So the framework itself is the lower level API. That's really about how you dig into the resources of the machine itself, how you factor them into something usable. And then the toolkit is a more abstracted upper layer API, and that's where you learn to manipulate the VM itself and do more lifecycle management, those types of things. So here's a couple of code snippets. These are not probably runnable, so caveat emptor if you try to do so, but this is just sort of so you get the joke. It basically shows you creating a, you get basically this virtualization machine configuration object, and that's where you apply your CPUs and memory. You plug in network, disk image, those types of things. Virt.io is a driver context you'll hear a lot. You've probably heard it in the past if you've used virtualization at all with VMware. It's more of an optimized and high-performing layer. Mac virtualization framework prefers and uses Virt.io by default. So in this example, we're plugging it in, we're setting it up, and we're spinning up an object. The second little snippet there is a demonstration of how devices can be extended. In this case, we're doing a 3D accelerated display with the hardware. So in the olden days of virtualization, you would build a Mac VM, you got what you got. You either tried to really wrangle the pass-through of the hardware or you just couldn't do it. So it limited the scope and use of the virtualization. Again, in this case, when you're starting to talk about the new framework, devices can pass straight through. You can get access to the Metal API. You can get access to 3D acceleration. It really kind of changes the capability of a virtual machine. But that's a lot of bother to code every time you want to do something like that. So lots of people have made lots of cool tools for your desktop. These can do a variety of things and have a variety of reasons for existing. Tart is one that you'll hear quite a bit about. These folks open sourced it, put QEMU, which is a old and reliable and super well-known framework for virtualization, but they integrated that to the hypervisor framework. So it's kind of the best of both worlds. QEMU will give you emulation and the ability to do things that you need for Linux and other things, Windows, where the hypervisor framework can take over when you start to lean into Apple concerns. It's a completely open platform, and you can play with it on your local machine. Another one is Virtual Buddy, and it's, again, another downloadable. It's more of an implementation of the framework itself. Again, it's specifically designed to be a sort of a desktop virtualization playground. Of course, front and center is Parallels. That is VMware. That is what people know and love to use Windows on their Mac, to use Linux on their Mac. It's a cousin to Fusion, which is a way to sort of provide blended cross-platform functionality on your Mac hardware. So that one tends to be more of a day-to-day use for your desktop. And then, down in the corner, we have another one up there called UTM. It's a good open source platform that provides a lot of flexibility and capability. And then down in the corner, we have one that I might know a little bit about called Orka Toolkit. We also felt like it was important for there to be a desktop tool that lets people sort of understand how virtual machines perform and how they can work on your Mac, because at least in my business, when we're trying to convince people that there's a hybrid and a cloud world, it's very much a journey for the customer to figure out what a VM even functions like, especially developers who are used to using their desktop, and then you're putting it in a container and you're putting it somewhere else, and figuring out where the problems lie and where the performance is becomes a significant challenge. So these kinds of tools give you an opportunity to lab on your local machine, to mess up, to do whatever you want, to get your configuration right, and to really get a feel for how the performance is going to go. So why should you use stuff in your business that's virtual? CI/CD, that's a big one. If you have developers, if you help developers, if you manage their environments, this is something that they are going to do. Apple obviously introduced Xcode Cloud a couple of years ago. We've been running CI tools for the better part of a decade at MacStadium. It's just what developers need to be quick and agile and iterative and handle their work. Testing, validating assumptions, regressions, interactions, configuration testing. You see a ton of this in obviously the MDM world, where you're building different flavors of your app, different flavors of your desktop, different flavors of your user profile, pushing it out, especially in security as well, where you're trying to do positive and negative things to a Mac OS and see what the results are. So this is a good place. And then scalability. Obviously, VMs allow you to take different versions of the hardware, different versions of the OS, jumble them all up, and move them rapidly back and forth across each other, up and down, and redistribute stuff all over the place. So there are places, though, where virtualization is still touchy. This is where I would say it's still evolving. When you start to get into things like nested virtualization, so what I mean by this is we're going to start up a Mac OS VM, we're going to put a development environment inside of it, then we're going to decide if we want it to do a cross-platform build, and then we're going to put Android in there, and then we're going to try to run the Android emulator inside the VM on Mac OS, on top of Mac OS, nothing but net. Sometimes that doesn't go so well, or even if it does go well, performance isn't exactly what you hoped it would be. But that's, again, because you're layering so much, and when you get to that level, you're actually not just doing virtualization, you're doing emulation. So you're actually virtualizing something with an emulator inside the virtualization and then running virtualization on top of the emulator. So as you can imagine, not so great. Device extension and integration. While I did say at the beginning the virtualization framework is completely designed to help you integrate and pull your devices together, on the other hand, outside in, trying to figure out things where you potentially want a testing device or a redirected device or something local like a camera presented something far away, it can be a bit tricky. It's not that it can't be done at all, it's just that it's not as straightforward as you would think it would be. And then when you get into MDM management, and all the MDM providers are doing a pretty solid job actually of keeping up with this one, but when it first came out, hypervisor framework provided quite a bit of a fit for if you wanted to use MDM inside your VM to actually manage the state of the VM. You can imagine presenting fake abstracted hardware to a tool that's designed to prevent fake abstracted hardware sort of cause people to have a little bit of an issue. There are a lot of different ways to adapt around it, but one of the big issues here specifically was the serial number for the hardware. A lot of MDM tools latch on exclusively to the serial number as an identifier and a unique identifier. Mac VMs don't let you modify that, don't let you provide uniqueness to that, and they basically steal the underlying hardware. So once you start creating 2, 3, and moving them around, you get lots of fishy serial numbers floating around your environment. So what does this mean? Well, it means Apple's working on a better way to present that serial number, which is also critical in using Xcode and your iCloud. But they're also providing different ways to interact with it. On the same time, MDM providers are finding different unique identifiers that are still kosher with Apple that allow you to manage the VM and move things around. Networking and IP management. This isn't so much a problem in VMs as much as it is a complication from a mental abstraction. You need to start thinking about hosts with IPs, with additional IPs, with DNS on top of that. So you've kind of got a layer cake going, right? So keeping track of how you're managing your IPs and your IP schemes and how you're doling out DNS. Early on in the framework, days, there was only a certain way you could create the IP on OS, so you could sort of run out of IP addresses fairly quickly. That's been fixed. But it can be a little bit of a tricky problem at scale. So let's apply Mac to your let's virtualize your organization. So, you know, there's a couple of different stages, not just virtualization, but automate and manage, virtualize and orchestrate, and then integrate and connect. And I say this because we've all used Mac forever. It's about the hardware. It's about what we can do with the hardware. So, you know, the first step in any organization is getting that hardware, deploying that hardware, and then figuring out how to control it. The power of virtualization really gets into distribution, orchestration, and other things. So that's kind of where it's the middle layer. And then once you get it wherever you need it to be, how do you integrate that to your other controls, other facilities, and how do you access it? So deploying your hardware, here's a quick example of, you know, you've got endpoints on desktops. You've got a collection of quote-unquote servers, I'll air quote servers. But they're the desktops and the things that we tend to use as servers. And then you can deploy those in the office and around, or if you look to the right, there's a data center with them in a rack. So you can scale them up in your closet or elsewhere. But at this point, you're basically distributing your hardware around, you're managing and automating it. This is where MDM comes in, and IDM, identity management. So this is where you're sort of roping everything into one collective whole. And then you're putting the networking together to access it. And this is strictly from a bare metal sense at this point. So a little pitch for us, but also it was an easy slide for me to explain bare metal. It basically provides you a cloud. If you put it in a closet, it's a way for your team to get into it and support it. I know all of you run admin organizations, so the more centralized you can make it, the easier you can support it. You can scale it a lot easier, and you can secure it. The next step is CI or orchestration, right? I know a lot of you maybe don't do CI specifically, but orchestration in general is something that is critical once you get your platform built. Again, this is where virtualization comes into play. You kind of aggregate everything together. In the development world, we use plugins and tools for CI. We use things like Orka, where we cloudify it, we integrate it. You want your developer to be developing. You want your user to be using. You don't want them to be mucking about with how to tie everything together. So a quick touch point as I go into Orka. It comes in a couple of different flavors, but again, this is a containerized, virtualized platform that takes hardware, wraps it up, and then delivers it where you can get to it either on the web. You can use it as a platform on AWS. You can use it in MacStadium. It's a platform for orchestrating. Once you get your stuff orchestrated and virtualized, though, you want to have access to all the things. So what does that mean? Well, if your pipeline's running in the background, it's going to run and spit back results, but you have repositories, you have caches, you have virtual desktops, you have test environments. So you want to provide your users ways to access those things, and that could be old school VPN tunnel with SSH or VNC. That could be something more forward-looking like HP Anywhere, which is a Teradici product, which provides a high-performance desktop, or our Orka Workspace desktop, which provides a protocol that we're releasing at this conference called Pulse, which is similar to your Teradici in that it's high-performance video and audio. But the big part about these platforms and what they offer when you put your capacity wherever you put it is that you're wrapping identity and configuration around it, you're wrapping scalability around it, you're wrapping auditability around it. So it's providing that gatekeeper to get to your things where they matter the most. So macOS virtual desktops. This is a weird subject because, again, Apple is absolutely about the experience with the device. Also, Apple is about extending the device and having other ways to interface to it, whether that's your watch, your phone. There could be goggles in the future, who knows. But virtual desktops are certainly a thing, whether it's just a second or third display or whether it's an actual VM. It doesn't necessarily supplant your Mac. So I think one of the mistakes people make when they get into virtualization is I'm just going to virtualize all my Macs and they're going to sit somewhere else and then I'm not going to have to worry about it. It's really more like augmentation or powering up or providing additional capability for your Mac. That doesn't mean you have to have a certain type of Mac where you sit, and it doesn't mean you're not going to ever have a Mac again. So it's a little bit of both, right? I can now use a lot of different flavors of Mac from the one flavor of Mac that I have. I can definitely have more flexibility as to what kind of OS and hardware I have backing what I'm trying to do in my Mac world. So these kinds of desktops can help you with that. They can eliminate sort of the hardware challenges that mix you up, and they can provide instant speed and scalability. So one of the things we see a lot is in the IT space, folks rolling out the latest version of Mac OS, rolling out different configurations of Mac OS, development teams who are basically on last, next, and beta, and they're trying to kind of keep track of all these different things and run it with a different tech refresh cycle on their endpoint. So kind of helping be the clutch between all those things is a really good space for virtual desktops. So here's an example of sort of how to combine your workflow from laptop to cloud. And virtualization, which I've been talking about this whole time, is sort of the oil, the friction reducer that does that. You take things like we talked about in the beginning where it's a TART or an Orka toolkit, and you get a localized environment that helps you understand configuration, performance, virtualization, how it all works together. You take this middle section, and we didn't dive too deep in that before, but containers are basically sort of shelled wrappers around things. OCI is an open standard. In this particular image, what I'm expressing is what we do with Orka and with technologies like Docker is we put an OCI compliant wrapper around your VM. What that is a turtle shell for your turtle. And now everybody's got sort of a similar turtle shell, and we can move them about in the cabin. We happen to use Kubernetes in Orka, which gives us a sort of open standard framework for moving things around, but you can use other frameworks and other orchestration tools as well. The joke is that it's an easy sort of standard interface way of moving things across environments, across hardware types, across platforms. Once you do that, you have a containerized stack, and that opens up the cloud. Cloud being stuff wherever it is not sitting next to you. So what happens when you put all this together? Well, again, kind of like I alluded to in the beginning, that's what I think we call Mac DevOps. I know we have IT and admin concerns, we have end user concerns, we have developer concerns. There's sort of all these worlds mixed together. But when it comes down to it, what we're trying to do is encapsulate the Mac experience for business and enterprise, not necessarily end user. And we're trying to make that a useful tool across your company. So it's assembling that end-to-end platform, and that includes a lot of things that I'm not even talking about today. Again, security and MDM and a whole litany of tools, and providing them in a sort of seamless way that lets you go from your desktop to your data center without a lot of hiccups or complications or a million different tools. So why? Well, again, the title of this thing was called Unlocking Virtualization, but really it's unlocking what we see as the future for Apple and the platform. It's enabling edge computing. Again, you want to be able to create that seamless portability and transmittability of your Mac tools and your Mac environment, so that encapsulates computing on the endpoint all the way into the cloud. It's going to help, and it does help, extend virtual displays and interactions. This is, a virtual desktop now. This could be a virtual display or a different kind of extended experience in the future. And then it orchestrates your compute, and that's really getting what you're doing task-specific or individualized so that the person doing the Mac things is doing the Mac things with the specific environment and the tooling that they need, and then they can move it wherever they want. So that's my ramble for today, everyone. But I hope you enjoyed it and learned a couple of things. Obviously, as a MacStadium guy, I'm a fan of our platforms and what they do to fit into this picture. But we are here at a booth. As I mentioned before, we have Orka Workspace, which is our virtual desktop display technology with a new component to it called Pulse, which we're pretty proud of. It's a high-performance, high-speed connectivity protocol. You can actually stop by and watch our product owner, Kimo Fouts. He is happy to show you how it works and play all sorts of cool videos and audio, and we think it's pretty neat. And then additionally, would love to talk to you about bare metal and Orka and all things Mac. We love all things Mac. So come by and see us. And that's it for me. Thanks, everybody.
Any questions?
Oh, that's a good point.
Questions.
Questions.
There's a couple of questions in the app, Chris, if nobody sticks their hand up.
All right. Anyone? No.
It was obviously very comprehensive. Thanks very much, Chris.
Mr. Bridge.
Oh, sorry, we've got one.
Oh, you're doing fine. Thanks, James. Appreciate you. Chris, good to see you as always. This is super awesome. As we go into, Worldwide Developers Conferences in, 2 weeks?
Yeah.
What's on your wish list for the virtualization framework as we go into the summer? What should we be looking for?
Oh, that's a good one. I kind of tipped on serial numbers, right? We have been actually meeting with the hypervisor framework team like on a quarterly cadence at this point because it's a work in progress. One of the things that I wanted to see, and I think it's in the latest OS, if I'm not mistaken, was a better handling of serial number generation and the ability to work with iCloud in the VM. That's a pretty big deal. With the virtual desktop side, device redirection was another one on the wish list. That was a interesting one to discuss with them of the why. But it looks like there's actually some pretty interesting audio and video optimizations in there as well. And then we just had a couple of bug fixy things, but I think those got fixed a couple of patches ago. But I am excited to see the maturity of it. It's an interesting conversation when you talk to them because they put it out for, like I said, a specific reason. Their worldview is kernel protection and that sort of thing. But the team understands virtualization very well. And when you say, well, we're used to using QEMU and it can do blah, they quickly go, oh, we see why you're going there. So hope that answers it. Cool.
Any more? So one from the app, Chris. What's the best software that's easy to use in your environment? Parallels or VM Fusion?
I would actually twist that question a little bit and say, that's sort of an end point. If you're trying to use just basically boot a Windows desktop on your Mac, there's parallels for that, right? If you really don't want the hassle of the OS itself, Fusion's the blend. But again, as I alluded to in my talk, I think virtualizing on the desktop is, you're probably trying, that's probably more of a business user implementation of virtualization. What I see a lot with admins, with developers, with technologists is they're really trying to accomplish something more than that, not just boot it up. So that's where I would, again, lean into UTM or Tart or Virtual Buddy or my personal favorite, Orka Toolkit. Come on, download it. Let's go. It's all free. And then those things kind of help you tinker a little bit deeper with Mac, but not only with the virtualization framework, but you can actually start to work with like integrations and tools and plugins a little differently than you would like booting up a whole OS and being stuck inside that OS.
Nearly. One more.
Okay.
If this hasn't been asked, what have been some of the difficult technical problems virtualizing Apple Silicon hardware for your customers?
Well, there was the whole Apple Silicon part at first. That was that was probably the biggest jump, as we were all really comfortable with Intel, and you know, as any good developer does, we don't invent, we cut and paste. So Intel was a great world where there was decades of technology based out there. So we all kind of had to learn from scratch with the hypervisor framework. And then, like I said, for Apple, the initial implementation could spin up a VM, but a lot of the capabilities that you're used to doing as a cloud provider or as a virtualization person, like ballooning and high performance networking and interactivity, those kinds of things, they weren't considerations initially. So it was a pretty difficult crawl the first year, trying to figure out how it worked, will it work, what will it do, what can it not do. And then honestly, the transition from Intel to Apple Silicon itself was, you know, even though you could get the VM to work, most of the things didn't work in it yet. Tools were still being written, software was still being written, and emulation exploded everywhere. And emulation, again, as we alluded to before, in a VM is not fun. So it was really trying to sort out what's working from what's not working over that sort of evolution that was the challenge.
Thanks. Anyone else? Thank you very much, Chris.
Awesome. Thank y'all. Appreciate it.